This table shows a random sample of 30 quantitative SAT scores, and we're asked to create a histogram for the scores here. And the series of bins that will be used for this exercise will be from 500 to 540, 540 to 580, and so on. And it adds in this condition that if an observation falls exactly on the boundary of two bins, put it in the left category. So like for example, here's a data point that has 540 that falls right on this boundary. It's saying don't group it here, group it here. If you click on, let's say like over here, click here to view histogram B, like, maybe this is the histogram, or if you look at this is histogram D, maybe this is how the data is made. What we can do is actually open this data in StatCrunch. So I'm going to click right here, and I'm going to go open in StatCrunch. Try that again. And it puts all this data into one column for us. So here are the 30 scores. If you want to make a histogram, the way you can do that is by going to where it says Graph. You can select Histogram, and it opens up this new table. Okay, you click var1. This is the column where the data is entered. We want a frequency that'll be a histogram, so I want to leave this as frequency. And I think the only thing that we'd like to add is for the bins, we want to start at 500. That's where it tells us where to start. And then the width of the bins, they tell us, is 40. And really, this should be enough. So like if you click compute, it gives you an actual picture of the histogram. And if you hover over it, it tells you like, okay, so for this bar, there's a frequency of 2, and it goes from 500 to 540, including 500, but actually not including 540. So it turns out that this is actually going to be slightly off. And the reason is the direction said we want that if an observation is on the boundary, it should go into the left bin as opposed to the right. And the way this one is set up, here, 540 is not included in this bin. So what we're going to do is edit this a little bit to make it look more like the correct histogram. If you click where it says Options and go to Edit, it'll take you back into this part here, and I'm just going to make an adjustment. I'm going to set the width to be 40.1. I just want to go a little bit past 40 just to make sure that I include 540 in the bin to the left as opposed to the right. So I'm going to click Compute and see what we get. So like if you look at this now, okay, this goes from 500 to 540.1, but that means it actually will include 540 in this column, which is exactly what we want. So this should be the histogram that we want, and we're going to match it up to the correct one over here. So, okay, I'll move this off to the side for now. Let's see what we got. So I'm going to open up histogram B. There's histogram B. And okay, that definitely does not match this picture here, so that's no good. I'll check out histogram D. Again, kind of looking at these side by side here. Okay, that actually looks good. In fact, I'm pretty confident that this is the correct one. We could go back and check out C and A, but I'm feeling this graph matches this one. Therefore, I'm just going to close this and check my answer. Okay, and it's correct. Great. Okay, furthermore, now it's asking us to use this histogram to answer this question here. So for example, is this data skewed left? Is it skewed right? Is it bell-shaped? Maybe it cannot be determined. To me, it doesn't really look bell-shaped. In fact, it kind of seems like the data is skewing to the left, just based on the shape of the distribution itself. So I'm going to go that this distribution appears to be skewed left. So I'll click here and check my answer. And the last part is identify any outliers. All right, so I think we can figure this out from the histogram as well. So let's see, an outlier is just going to be something that is far away from the center of the data. And over here, I'm guessing this data point is going to be the outlier, just because we have the middle of the data is around here. This seems to be kind of far away. There's only one thing in this bin, because the frequency is 1. And since it's centered here at 800, if I look over at my data carefully here, just kind of like quickly scan it. Okay, I think that has to be referring to this number, 794. That is something that would fall within this bin. So it does appear that there is an outlier for this data, and that would have to be the score of 794. Okay, that is it for this question.